Section 11-3, sector area and arc length. The objectives of this lesson will be to find the area of sectors and to find arc lengths. Okay, we're going to start off with finding the equation for a sector of a circle. A sector of a circle is a region bound by two radii and their intercepted arc. So here, this is the radius, the radii I should say, and this is the arc that's in between those radii. This is the sector of an area. The equation to find the sector area, or the sector of a circle, is pi r squared times m degrees over 360. Now this m right here represents the central angle. Okay, so m is your central angle. And the central angle can be found right here. This is your arc angle, which is your central angle. Okay, let's go ahead and start an example. So let's find the area of the sector, give answers in terms of pi, and round it to the nearest hundredth. Okay, so we want to find this area right here. We have the equation already set up for us. So to find the sector area, we do pi times your radius, which is 12, times your central angle. Okay, the central angle is your arc angle, which is the same. So this angle right here is the same as this angle. So 131 divided by 360. And that's it. We just plug this in. We're going to go ahead and leave this in terms of pi. And we get 4.37 if we round pi. Okay, so this is the area of the sector, this part right here. Example 2. A windshield wiper blade is 18 inches long. To the nearest square inch, what is the area covered by the blade as it rotates through an angle of 122? Okay, so let's say we have our windshield wiper here. And it wipes around, it comes over, and then it comes right back down. Okay, so this is about what our windshield wiper looks like. It says it rotates through an angle of 122 degrees. So that right there is my central angle, or you can do the arc angle. And we're told that it is 18 inches long. So 18 inches, that's the radius right there. So what is the area covered by the blade? So we have everything we need. We can go ahead and plug this into our equation. The radius is 18. The central angle is 122. And now we are ready to plug this in. Okay, and for this we get 61.1 pi if we leave this in terms of pi. If not, you would end up with a different decimal. Either way. Okay, now we have the segment of a circle, which is a region inside a circle bound by a chord and an arc. So right here, this is the segment of a circle. And here we have the area of the sector. And if you subtract this piece, what remains is that segment of a circle. Okay, example 3. Find the area of segment RST to the nearest hundredth. So they just want the area of the segment. So just this green piece right here. So notice here, we're given this triangle. We know that this right here is 4. So we can also say that this right here is 4. And we know that this makes a triangle. So we can use the equation for area of a triangle and find how much area this takes up. So I'm going to start off with that first. So area of the triangle we know is base times height divided by 2. So since it's a right triangle, we can use the base for 4 and the height as well is 4, and take that and divide by 2. 4 times 4 is 16, divided by 2 is 8. So the area of this triangle is 8. Now I only want this green part right here. So I'm going to use the area of a sector. So the area of the sector is going to give me all of this area right here. And then I'm going to subtract the area of the triangle that I found. And what will remain is this green part right here. So for the area of the sector, you had pi times the radius squared times your central angle divided by 360 degrees. We know that the radius is 4. And our central angle right here is a right angle, so that's 90 degrees, and divide that by 360. Okay, so the area is 12.57, so that's the area of the sector, and I only want the area of the segment, so we're going to subtract those. So 12.57 minus the area of the triangle leaves me with a total area of 4.57. Okay, now we're going to talk about arc length. Now don't confuse arc length with the arc angle. In section 2 you learned that this angle right here, your central angle, is the same as the arc angle. Now that is an angle. Right now we're talking about the arc length. So length is a measurement. So arc length is the distance along an arc measured in linear units. And the equation for that is 2 pi r times your central angle divided by 360. And this will give you a length, meaning a length in centimeters, meters, inches. Okay, it's measured in linear units, whereas an arc angle is measured in degrees. So make sure you don't confuse both of them. So here in example 4, they're asking us to find each arc length and to give our answers in terms of pi and round it to the nearest hundredth. We'll just do the pi. So they want the arc length of arc FG. Now if we were to connect this right here, if this is 134, we also know that this is 134 degrees. Okay, so your central angle and your arc angle are the same, but they want us to find the arc length. So to find the arc length, we're going to use the equation for arc length, which has us do 2 times pi times your radius, which we're told is 8, times the central angle divided by 360. So our angle is 134 degrees over 360. So our arc length is 5.96 pi. Okay, so that is all. Make sure you write the equations for your arc length and your sector area and the segment of a circle, and have them ready so that you can use it on your worksheets.